So the question submitted to the definition derivative lecture occurs at about 1 minute and 15 seconds into the lecture, where you see the f of x line shown here moving towards the f of x plus h line as we apply the limit as h goes to 0. And the question is simply, why doesn't the f of x plus h line move towards the f of x line? After all, h is shrinking. X isn't getting bigger, h is shrinking. That's the question, and this is a great question. This is actually more or less an editing, I don't want to say mistake on our part, but it's something that could have been improved. If we did it the other way around, it would be better to show the f of x plus h line moving towards f of x. Technically speaking, because f of x isn't constrained, f of x is constrained, x has to be in the domain of f of x. But beyond that, we can pick our f of x anywhere. It's just a random variable. We haven't defined it at this point. So, technically speaking, the way we did this isn't correct, but ultimately everything's about a matter of optimization. And if we had to do it again, we would do it the other way that our user suggested to us. So, great question. Keep sending them in. For the rest of you who are learning this lecture here, and the thing to really just keep in mind is understanding the illustration that h is getting infinitely small. As h gets smaller and smaller, our approximation of the derivative gets better and better. I'm going to show this by stopping here. We have a really, really bad approximation for the rate of change at f of x. We let it get a little bit smaller, all of a sudden, at least our tangent line's going. Our secant line is going in the right direction. Secant line when there's 2 points, tangent when there's 1. And as x gets really, really small, that line zones in until it's only hitting at 1 point, and that's our derivative. So understand this from an illustrative perspective. Like I said before, this detail would be one that we'd want to fix in the future, but it does get the point across that h gets infinitely small. Thanks for sending in the question. Please send us more, and glad to help you guys through Free Academy.